And here I want to come across, I'm going to make another graph here. And let's just, let's pretend we look at different houses. Huh? And let's say we look at the number of bedrooms and the number of closets. Okay, so we go to one house. It has 3 bedrooms, and we count how many closets exist in this 3-bedroom house. Maybe it has 6 closets. Who knows? Okay, and then we go to another house. It has 3 bedrooms, and we count how many closets. It has five closets or something. Okay. And then another house has 4 bedrooms and it has 5 closets, maybe 4 bedrooms and 7 closets. Maybe we find a 2-bedroom house with 2 closets, and just help me out here. Maybe we find a 1-bedroom apartment with 2 closets. Okay, sure. And another 2-bedroom place, and maybe it has 4 closets. Okay, sure. And let's say there's a 5-bedroom place. How many closets do you think it has? 7 closets, sure. And a 4-bedroom place, it's got 6 closets, and another 2-bedroom place, and it has 3 closets or something. Okay? Is this okay?
Yes.
So this is, so you don't have to copy the data down into your notes, okay? That's, but just basically, if you copy the first few lines, that's fine, okay? And here we are, in this equation, we are predicting the number of closets based on the number of bedrooms, okay? And our line of fit, according to Excel, is this, 1.3571x, 0.6286 plus 0.6286, okay? So I'll put this up, okay? Say here. Okay, well, you can look at the data itself, okay? But, we can see here's a place with 3 bedrooms and 5 closets. So we can see on the vertical axis we have closets over here, and this is the number of bedrooms. So the Y is closets, that's correct. And X is the number of bedrooms. Okay. All right, so let's just, and can you guys see this prediction equation here? Okay, so I have y hat, or y is equal to 1.3571x plus 0.6286. Okay, so let's just do a quick exercise here, and we will say, in the newspaper or in the classifieds, a house is listed. It has 4 bedrooms. Okay, how many closets do you predict this house has? So in the classified ads, a house is listed, okay? This is just putting some context in there, okay? It's not critical, okay? But it just, a house is listed, it's got 4 bedrooms. how many closets do you predict this house to have? Okay? And then we will say, you visit the house. So this is part A. This is going to be one question. Okay, you visit the house.
I'm sorry, which is part A, the top?
Yeah, part A. Okay, and then part B. You visit the house. It actually has 6 closets. What is the residual? Okay, so it says in the classifieds, a house is listed. It's listed as having 4 bedrooms. Okay, so I want to know how many closets do you predict this house will have? And then when you visit the house, you count how many closets it has, and it has 6 of them. So what is the residual for this house? Okay. I'm sorry? Yeah. Okay, so take a couple minutes to work this out. Okay, we'll get started here in working through them. So, all right, let me get your attention back here. Okay. All right, so we want to predict how many closets the place has. Okay. So we're going to predict by plugging in the value we have for x, and we're going to get back a y. Okay. So for the prediction, okay, we plug in x into the equation, okay, and the y we get back is our prediction. Okay, so all you have to do is you just do 1.3571 times x, so we plug in a 4, because that's how many bedrooms we have, and then we add 0.06286, and we punch that into our, I'm sorry? Okay, so we punch that into our calculator, and we get 6.057. Is that good? So we predict the house will have 6.057 closets. Now, of course, the house won't actually have 6.057 because it can only have a whole number of closets. It will either have 5 closets or 6 closets or 7 closets or some other closet. Even if it's like a linen closet, that counts as a closet. You don't say that's only half a closet, okay? Now, I mean, sometimes with bathrooms we do that, but in general, we're just going to say this is how many closets it has. Okay? And so if the house actually has 6 closets, what is the residual? So we know our residual is always the actual value, in this case 6, minus our prediction, which is 6.057. So we get a residual of negative 0.057. Okay? So this means the actual house had 0.057 fewer closets than our prediction. Okay, but of course, when we make a prediction, we're getting a decimal, and that's just not possible. Okay.
So that answer would be kind of like we would be really, really close to that.
So yeah, so in this case, our model, our linear equation line, did a very good job of predicting the actual value. Okay. Now, if we went to another house, though, maybe it has 4 bedrooms and it has 7 closets, okay? Then we would be off by almost 1, 0.943 or something like that, okay? So sometimes a data point fits very much what the prediction line is like. Sometimes a data point doesn't, okay? So, so this is what we say, things that are, quote, typical are the ones that are close to the line, and things that we might consider unusual are data points that are far away from the line. So if you found a house with 4 bedrooms and it had 0 closets, you would say that's unusual, okay? You would say most houses with 4 bedrooms have at least 1 closet, okay? But, maybe it's some modern design thing where they don't do closets or something, we don't know, okay? Or maybe, or you could find another house, 4 bedrooms, 10 closets or something, and you say, wow, this place has a lot of closets, and they might list it in the ad, right? Like closets for days or something, whatever you want, okay? And then someone else might say, well, I don't want 10 closets in my 4-bedroom house, whatever you, okay? So sometimes the data points are very close to our predictions, sometimes they're far away. Okay, let's keep this in mind, and let's try, I want to just expand on this concept here, okay? Okay, so we're still going to deal with our closet and our bedrooms and closets idea. And I want to talk about the slope. Okay, so we went back and we said y is equal to mx plus b, okay, where m is the slope and b is our intercept. Okay, so in our equation we have y equal to 1.3571x plus the b, which is 0.6286. Okay, so what is our slope? Our slope is 1.3571. And what is our intercept? 0.6286. Okay, so if you're given an equation, you should be able to identify the slope and the intercept. So I want to talk about what this slope means, okay? And so to illustrate this, okay, how many closets do you predict? And you can make a little table. How many closets do you predict if the house has ... 3 bedrooms? Make a little table. 4 bedrooms. 5 bedrooms. Okay, and so for 4, we already got the answer, and what do we say? 6.0576, is that what we said? I already forget. 6.057, okay, great. Okay, so I want you to make predictions for houses with 3 bedrooms and houses with 5 bedrooms. Okay, do you guys need another minute? Okay, so I've already filled in the numbers, but see if your numbers that you get match mine, okay? So basically I just said if the house has 3 bedrooms, how many closets do you predict? If the house has 4 bedrooms, how many closets do you predict? If the house has 5 bedrooms, how many closets do you predict, okay? So this would be the predicted closets. Okay, so go ahead. You can go, if you're watching on YouTube, you can pause the video and make sure you can arrive at these numbers. Okay, so do we all arrive at 3 bedrooms, 4 bedrooms, and 5 bedrooms, okay? Okay. So here's another question. How much bigger is your prediction for 4 bedrooms than it is for 3 bedrooms? And how much bigger is your prediction for 5 bedrooms over 4 bedrooms? Okay? Yeah, so remember, these are our predictions. So what do you have to add to this prediction to get to this number? That's my question, okay? No? Okay, so all right, okay, so just listen carefully, okay? So I want to know, so here I have 4.6999, okay? And I have 6.0571, okay? What do I have to add to this number to get to this, right? So when the house had 3 bedrooms, I predicted it had this many closets. When the house has 4 bedrooms, again, this is my prediction. I'm predicting it to have this much. How much did my prediction change by changing it from 3 bedrooms to 4 bedrooms? That's my question. Okay? So what should I do? I would do 6.057, 4.6999. Okay, and what's the difference? 1.3571. Do we see that? Okay? Okay, same question. How much does it change to go from here to here? To go from 4 bedrooms to 5 bedrooms? So I would do 7.4141 minus 6.057, and what do I get? I get 1.3571. Okay? Yeah, it's the same answer. It is the same answer, okay? All right, so without plugging in all of the numbers here, so if I write 6 bedrooms, okay, what do you think we would do to get this number?
8.3571.
Okay. All right, so you guys, some of you are excited. Okay, we're going to just add what? 1.3571. Okay, so I do 7.414, 7.4141 plus 1.3571, and I get 8.772. Okay? Wait, I forget. 7712. Okay? So I do that, and I get that, okay? And we could verify, we can type in 6 times this plus this, and I promise you, we would get 8.7712, okay? Is this okay with everybody? Okay. So yeah, okay, so all right, so let me explain, but I just want to make sure everybody can see what's happening. To go from this prediction to this prediction, we added 1.3571. To go from this prediction to this prediction, we added the same number. To go from this prediction to this prediction, we add 1.3571, okay? What is that number? That number is our slope. This is the slope here, okay? It's not a coincidence that they're all the same, okay? This is the meaning of the slope in this problem, okay? It's the meaning of the slope. So this is a tough concept, but if you were to try to explain this, so I want you to take a minute and see if you can try to explain what's happening here to someone else. What would you say? It's the same, okay? Where each time our prediction for what? The number of closets goes up by 1.3571, which is the amount of our slope, if we do what to the number of bedrooms? If we add 1 bedroom, okay? So just
Yeah.
Okay, I know you guys.
So what is our prediction? Is our prediction of the slope?
No. So listen. Okay, so let me explain this. We are going from 3 bedrooms to 4 bedrooms to 5 bedrooms to 6 bedrooms. Each time we are adding 1 bedroom, what happens to our prediction? Our prediction goes up by 1.3571 every time I add 1 bedroom. Okay, so another way to think of this is that our prediction increases by the amount of the slope when I add 1 to the x variable, in our case bedroom. So if I add 1 to x, or if I add 1 bedroom, my prediction for closets goes up by the slope. Okay? That's an important interpretation. Okay? So say that to yourself again, okay?
What is called a myth?
Hmm?
What is called a myth? To add 1 bedroom and the same, it has some.
Okay, so maybe let me write this down. Okay, now remember this is a prediction, okay,
Yeah.
and it's not just like everything else. It's just a prediction. It doesn't mean the house will actually have that. Okay, but let me write down our interpretation of the slope here. Okay, so the interpretation or the meaning of the slope. Okay, so if we add 1 to x, our prediction for y changes by the amount of the slope. Okay? So in the context of the problem, what we write is, okay, if a house has 1 more bedroom than another house, okay, our prediction for the number of closets in this house is 1.3571 more than the prediction for the other house.
So the slope is what goes up.
Okay, so the slope is the amount our predictions, and it's very important that we use the word prediction, because if we compare a house with 4 bedrooms and a house with 5 bedrooms, the difference between the number of closets is not going to be 1.3571, okay? But our prediction for the number of closets changes by 1.3571. Okay? Okay. Does that make sense? Are we okay? So let's try another problem here. Okay, I'm going to just make something up. Okay, and so let's say we have an x variable and a y variable. We're going to predict, we'll say x is height and y is weight. Okay, and let me just, don't hold me to this. Okay, so don't copy those numbers down. Okay, all right. So let's say our prediction line y hat is equal to 5x minus 180. Okay. So I'm going to just put up a few kind of rhetorical questions just to kind of re-emphasize the points here. Okay. So, so what variable are we trying to predict? Okay, we're trying to predict y, which is the weight. We're trying to predict the weight. What variable do we use to make our prediction? And that's x, the height. So we say if somebody gives me the height of someone, we're going to use that to make a prediction for the weight. Okay, so this is just a very simplified equation. We're going to say y is equal to 5x minus 180. Okay. So here, if someone is 60 inches, 5 feet tall, what do we predict this person's weight to be? So if someone is 60 inches tall, what do we predict this person's weight to be? We would do y hat is equal to 5 times 60 minus 180. I get 300 minus 180 equal to 120. So we predict this person weighs 120 pounds. Okay? You just plug in 60 right here for x. Okay? Okay. So now, what is, okay? I'm going to ask, what is the slope? The slope is 5. Can we see that? Okay, the slope is 5 because we have the number in front of the x, that's the slope. What do we call the negative 180? The intercept. Okay, so what is the slope? The slope is 5. What is the intercept? Okay, the intercept is negative 180. Okay, okay, because it's a minus. Because doing a minus is the same thing as adding a negative, right? And so it's always in the form of y equals mx plus b. So in this case, we're adding a negative 180. Okay, right? We can.
So the 5 is the number of.
So yeah. So what does it mean that our slope is 5?
Yeah.
What is the interpretation of the slope?
So is that 5 people?
No.
Or 5 feet, I mean?
No. Shh. Okay. So let me. So let's see. What is the interpretation of the slope? Okay. So let's flip back a slide. Okay. And it says if we add 1 to x, our prediction for y changes by the amount of the slope. Okay? So think of what x is and what y is. All right? So don't shout out any answers, okay? But think about what x is and think about what y is. If we add 1 to x, our prediction for y changes by the amount of the slope. If we add 1 to x, our prediction for y changes by the amount of the slope. Okay? So x is height, y is weight, slope is 5. If we add 1 to x, if we add 1 to the height, our prediction for y, or the weight, changes by the slope. Are we able to process the words that I'm saying? If we add... Okay, and I apologize for those of you who got this a long time ago. I just want to make sure everybody's on board here, okay? If we add 1 to x, our prediction for y changes by the amount of the slope, okay? So height is x. So if I'm saying, what does it mean to add 1 to the height? We're adding 1 inch to the height, okay? So if we find another person who is 1 inch taller, our prediction for what? Their weight, our prediction for the weight is going to be what? 5 pounds more, okay? So every time we add 1 inch to someone's height, so here, what do we said somebody is 60 inches tall, we predicted this person's weight to be 120 pounds. If somebody else comes along and is 61 inches tall, what do we predict that person's weight to be? 125, okay? Okay, so let's say somebody comes in 70 inches tall. So 70 inches is 10 inches taller than 60 inches. How much do we predict this person to weigh? 170. We would predict 50 pounds more, right? Because each inch is, according to our formula, is worth 5 pounds, right? So if somebody comes in at 70 inches, 10 inches taller, each inch is worth 5 pounds, so we're going to add 50 pounds. Okay? Does this make sense? Can we do this? Okay, so the interpretation of the slope is if we add 1 inch to the height, okay? Okay. Our prediction for the weight increases by 5 pounds. Okay? And that kind of makes sense, right? Now, of course, it doesn't always work this way. But this is our predictions, okay? And this is just a rough guide for predictions, okay? We're just saying we add 1 inch to the height. Our prediction for weight goes up 5 pounds, okay? So with the slope, we don't even have to plug in all the math again, okay? If I tell you a 60-inch person is predicted to weigh 120, and I tell you the slope is 5, you don't have to do any extra math. You don't have to plug in 61 or anything. I say
The extra inches
you
multiplied
just
to the 5.
you just add 5. Exactly. Okay. So based on this, what do we predict? What is the predicted weight of someone who is 61 inches? Okay, we would do 120 plus 5 is equal to 125 pounds. We predict a person who is 5'1" to weigh 125 pounds. Kind of, sort of, okay? Okay, so let's do another example, and maybe I'll put up similar questions, but with different numbers, of course, okay? Okay, so I'll go ahead and start passing out the sign-out sheets. Don't leave just because you signed it, okay? But we'll see. Okay. All right. So let's say, in this case, X will be the age of a car in years. Y is the resale value of the car. Okay, and so our prediction equation is going to be y hat is equal to negative, we'll say 1100x plus $22,000. Okay, so I will ask, what are we trying to predict? What do we use to make the prediction? What is the slope? How much do we predict the car to be worth? After 5 years. What is the interpretation of the slope? Okay. So take this time and see if you can answer these questions. Okay, so I'm going to if you're watching on YouTube again or something like that, now's a good time to pause, because when in a few seconds we're going to go over the answers. So I'm going to pause this here. Okay, so what are we trying to predict? Resale value of the car. What do we use to make the prediction? Age of the car. Okay, now we know that all sorts of things affect the resale value of the car, but one of those things is going to be the age. Okay, what is the slope? Minus 1100. Okay, so how much do we predict the car to be worth after 5 years? Yeah, 16,500. Is that what we got? Okay, you just plug in 5 to this. Okay, and what is the interpretation of the slope? So that means every year the car ages, right? That's what it means to add 1 to x, right? The slope is every time we add 1 to x, our prediction for y changes by the slope. So to add 1 to x means every year the car ages, okay, our prediction, and it's absolutely important that you keep this word prediction in there, because it doesn't mean, if you don't do prediction, it means this will happen, okay? It's not that this will happen, it's our prediction, okay? Our prediction for the value of the car, decreases it goes down, decreases by how much? $1,100, okay? So pretty much every month, at least according, how did I get 16,500? I did negative 1,100 times 5 plus 22,000. So I would get negative 5,500 plus 22,000, and that should give you 16,500. Okay. Okay. So does this make sense? The interpretation of the slope. Make sure you have the word prediction in there. Every year the car ages, our prediction for the value of the car decreases by 1,100. Doesn't mean the car definitely goes down 1,100. It might go down more than that. It might go down less than that. Okay, but we're predicting that's how much it changes. Okay, so every month you own your car, you can expect about $100 in your resale value to go down about 100 to maybe more than that, depending on if you're a heavy driver or not. Okay. All right. There's so just another slide here. Okay. Sorry. I know we're getting ready to get out of here. Okay. All right. So all of this we have. This all relates back to, do you guys remember correlation, right? So R is the correlation. Okay. And so maybe, okay, R is correlation. And here's one thing to know, okay? If R is negative, the slope is also negative. So in our car depreciation thing, our slope was negative, right? It was negative 1,100. That means in that case, R must also be negative, okay? And if R is positive, the slope is also positive. So in the height and weight, we had a positive slope. The R is also positive, okay? The slope is also positive. Okay. We have something, if you take the value R and you multiply it by itself, okay? So if you take R and you multiply it by R, you get r squared, and r squared we write with a capital R, okay? This has a fancy name. Don't be deterred by its fancy name. Okay, so little r is called correlation. When we square r, take that value r and we square it, it gets a fancy name called the coefficient of determination, okay? It's a fancy name. Don't be deterred by it, okay? Of determination, okay? And so let's say, for example, let's say in our car depreciation value, for the car value example, let's say, and I didn't report this to you, but let's say R was equal to negative 0.8, okay? So we go back a slide. Okay, I didn't write this there, but let's say R was negative 0.8, and that's why we have a negative slope of $1,100, okay? What would R squared be? We would take R, and it would be positive, right? Anytime you multiply a negative by itself, you get a positive. So R squared is always positive, okay? So we do negative 0.8 times negative 0.8, and we would get positive 0.64, okay? Is that okay with everyone? So R squared, our coefficient of determination, this fancy name, is 64, okay? All right, and this is a loose interpretation, but it's kind of the most layman interpretation that I can give for R squared, okay? It is the percentage, or the percentage of y that is explained by x, okay? So just write that down, the percentage of y that is explained by x, okay? So this, so I'm going to put it in the context of this problem, okay? So when you resell a car, there's all sorts of things that factor into the price of the car, right? One of those things is age, but other things are the, the condition, the mileage, all sorts of other things, right? Does the AC still work? All of these different things factor into how much you're going to get for the car, okay? What this R squared tells us is that about the age of the car explains about 64% of that number you get, okay? That number you get, about 64% of it is explained by age. Now, and that's because age is often related to all of these other things, like mileage highly correlates with age, meaning high age goes with high mileage, things like that. So a lot of things go together, and in this case, we would say, so I'm going to write, many things affect the price of a car. Okay, R squared equals 0.64, so 64% of the car's value is explained by the age. Okay. So I'll let you guys write that down, and I'm just going to verbally say a few other examples, okay? And I just want to make sure that what I'm saying makes sense, or if you're watching, you can hear it and make sure it makes sense. So let's say we did the height and weight example, okay? Now we have a scatter plot, we can get correlation R. Let's say R turned out to be 0.6, okay? So when we do R squared, 0.6 squared turns out to be 0.36, okay? So that means, okay, remember what we were doing is we were trying to explain weight by height. Now we know people's weight, there's all sorts of things that affect someone's weight, you know, their body type, what they eat, all of these other things, you know, go into how much someone weighs, but height plays into it, and what we're saying is that 36% of someone's weight can be explained by their height. Does that make sense? Okay, so also, you know, this is also one thing you're responsible for, is that r squared, okay, oftentimes when you get a scatter plot, sometimes they'll have this, the equation, and they might also have the r squared in there. They often show that in there, except here it's tiny, but they might throw this in there, okay? And so in this case it says 92%, okay, and this is a terrible example, but 92% of whatever can be explained by the different things, okay? So if we were doing houses and closets, okay, we can say 92% of the number of closets in a house can be explained by how many bedrooms are in the house, okay? So that's what r squared is, okay? And so I anticipate that at some point in the future you will probably see some scatter plots, okay? I'm not worried about you calculating all of these things individually by themselves, but the interpretation of all of this stuff is very important, and using that scatter plot to then make another prediction is also very important, okay? Give me a day or two to get your homework assignment posted, and as well as information about the test. We'll see you guys next week.